Okay, a jar contains a red marble, a green marble, and a blue marble, and you draw 2 marbles in a row without replacing the first one. What is the probability of the first marble being red or yellow? So I could pull out a red, then a green. I could pull out a red, then a blue. That's an R. I could pull out a green and then a red. I could pull out a green, then a blue. I could pull out a blue, then a green, or I could pull out a blue, then a red. What is the probability of the first marble being red or yellow? Well, obviously we don't have any yellow marbles, so red, we have 2 possibilities out of 6. Alright, unions and intersections. When you think about a union would be like getting married, because we call marriage a union. So what happens is you have a bride and a groom. So you have the bride's family, the groom's family, they come together and become one big family. Now the trick here is that in a real union, you have some that are on one side, some that are on the other side, and then sometimes you have some that are both events. So that would be people who are on both sides of the family. So we're not really going to go there. Intersection. Intersection is like an intersection on a road. Intersection is the part of the road that they share. So that would be where they're overlapping. So union, you're going to have a U, so A union B means everything that's in A, everything that's in B. Intersection is everything that is in both A and B. Alright, mutually exclusive means that they don't have anything in common. So this empty set says nothing in common, or means no elements. So A and B says there's nothing that is in both A and B. So they're mutually exclusive, meaning there's nothing in common. So if they're mutually exclusive, you can find the union by adding together the 2 probabilities. Okay. So a card is drawn from a standard deck of cards. Now I've learned my lesson about putting card questions on tests. No matter how much poker you've played, people still don't know what's in a deck of cards. So we'll just do these examples just for the sake of having examples, but don't expect to have card questions on a quiz or a test. So a card is drawn from the standard deck of cards. Let A be the event that a card is a face card. Alright, so answer this one up here. There are 52 cards in a deck. Face cards, king, queen, jack, and there's 4 suits, so there's 12 out of 52 are face cards. Let B be the event that the card is black 5. Well, there is 1 5 per suit, and there's 2 black suits, so that is 2 out of 52. So we want to find and interpret A union B. Well, there's no overlap here. So we want the probability that the card is either a face card or a black 5, and the probability of that is 14 out of 52. Since there's no overlap, we can just add those together. So the complement of an event. Complement of event is written as the event with a line over it is a complement. So here we have a circle, and inside the circle is the event. So let's say that that is everybody in this event are people who wore flip-flops to school today. So The sample space is everybody who came to school. The event is those people who wore flip-flops, so the complement of the event is those that did not wear flip-flops. So everybody outside the circle did not wear flip-flops. Everybody in the circle wore flip-flops. So that's E complement, means that they did not wear flip-flops. So what we have going on here is you have the event and you have not the event. So the two have to add up to 1. So if you know the probability of one of the events or the complement, then what you can do is take 1 minus that probability and find the other. Okay, we have a matching game. And first Carolyn is to choose a whole number from 1 to 4. And then Mary guesses a number from 1 to 4. And we want to know what is the probability that the numbers are equal and what is the probability that the numbers are unequal. So Carolyn chooses a number from 1 to 4 and Mary chooses a number from 1 to 4. So we have 1, 1, 1, 2, 1, 3, and 1, 4. That's with Carolyn choosing a 1 and then Mary guessing. Or you could have 2, 1, 2, 2, 2, 3, 2, 4. Then you can do the same thing with 3, 3, 1, 3, 2, 3, 3, and 3, 4. And then 4, 1, 4, 2, 4, 3, and 4, 4. So that's 16 possibilities. So the numbers are equal 4 of the 16. Probability that the numbers are not equal or unequal. Well, quicker than counting the ones that are unequal, you could take 1, which is 16 over 16, and subtract 4/16, and that leaves you with 12/16. So 1 minus the probability of the first one gives you the complement, the probability of the complement. So we have a diagram here, and the sample space is the rectangle, and then the dots are your outcomes. So what we want to do is we want to, if we randomly choose a dot, what is the probability that the dot is in the sample space? Well, the probability there is 1. Because if we choose one of these dots, it is in the sample space. This says, what is the probability if we choose a dot that is not in the sample space? Well, the probability there is 0, because all of the dots are in the sample space. What is the probability that the dot is in A? Well, there's 1, 2, 3, 4, 5 dots. And there's a total of 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5 out of 15. B, 1, 2, 3, 4, 5, 6 out of 15. C, 3 out of 15. A union B. A union B. Remember, family A comes together with family B. How many people do you have in this new family? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 15. A intersect B. We want to find that part of the road where A and B share. A and B share 2 dots. 2 out of 15. A union C. So family A comes together with family C. A has 1, 2, 3, 4, 5 dots in it. C has 3 dots in it. So that's a total of 8/15. The complement of C, so not in C. Well, we have 3 in C, so that means we must have 12 that are not in C. Alright, couple of properties. Probability. Your probability is always going to be between 0 and 1. The smaller it is, the less likely it is to occur. So a probability of 0 means that it will never occur. Probability of 1 means it will always occur. Number 4. If you have mutually exclusive events, meaning there's no overlap, they don't share anything, then the union, the probability of the union, is just the sum of the probabilities. But if you have some overlap, what you're going to have to do is you're going to have to subtract how many items are in, or the probability of the items that are in the overlap. And then here again, the probability of the complement is equal to 1 minus the probability of the event. Alright, we have an experiment that consists of spinning the spinner once and recording the number on which it lands. So we have the numbers 1 through 8. They're all the same size, so they're equally likely. So, define the 4 events. An even number. Well, an even number would be 2, 4, 6, or 8. A number greater than 5 would be 6, 7, or 8. A number less than 3, 1 or 2. A number other than 2, 1, 3, 4, 5, 6, 7, and 8. So find the probability of A, the probability of B, the probability of C, and the probability of D. Well, probability of A, there's 4 in a sample space of 8. B, 3 in a sample space of 8. C, 2 in a sample space of 8. And D is 7 in a sample space of 8. Find and interpret A union B. We want a number that is either even or greater than 5. So that is 1, 2, 3, 4, 5, 6, 7, but we have 2 that overlap, so there are 5 numbers. So 5 eighths. We want a number for P, the probability of A intersect B. We want what A and B have in common. Well, A and B have 6 and 8 in common, so that probability is 2 out of 8. Last one. Find and interpret probability of B union C. We want a number that is greater than 5 or a number that is less than 3. So what we have is 5 out of 8 numbers fit that interpretation. Here we want the probability that the number is greater than 5 and it is less than 3. Well, we don't have any numbers that are bigger than 5 and less than 3, so the probability there is 0.